Hello and welcome to episode 3 of our tutorial series, where we'll be making a DirectX ready game engine. In this episode, we're going to be building a new project to act as our game engine. We'll be creating this as a dynamic linked library, or a DLL for short, and we're going to find out exactly what's needed to be able to link this into our blank project program. We'll then be looking into how to build the basic framework for our game engine, including a generic back-end entry system. At the end of this episode, we will have a simple structured game engine to power our future projects on. So with that being said, let's get on with it. Let's start this episode the same as we have for the last two episodes and go straight to the Olympus Mons folder. We need to create an episode 3 folder, and for this I'm just going to duplicate the episode 2 folder and change the name. We've done this in the last 2 episodes and we're going to do it in every episode going forward, so please note that this is the last time I'm going to include this step in this series. Now we've created our episode 3 folder, we can go inside it and open our Olypus Engine solution that we created in the last episode. Now the Visual Studio is fully loaded, we can see the blank project program that we've been working on. This program is going to represent the game that we're actually making, but what we need now is an engine to be able to run it on. We could build our engine directly into our blank project program, but that means we wouldn't be able to use it to run other programs later. What we'd really like is a scalable engine that can be used in a multitude of different programs. And for this reason, we need to create a new project to act as our engine. To do this, let's come up to our solution, right click, click on Add, and New Project. Just the same as before, there are lots of great templates that Microsoft provides us, but we're just going to choose Blank Project and Next. We already have a name for our solution, so this will just be where to store it and a name for our project. I'm going to leave the location as it is predefined, but let's change the name to Olympus. Once that's done, we can just click on Create, and that will give us a new project for our engine to work from. We now have a project to work as our game, and we have a project to work as our engine that we can then link into our game project. Just the same as the last project, we're going to change this to private and public and resources and set this up in a way that's nice and easy to remember. I'm going to try and skip through this section as quickly as possible because we've already learned how to do all of this in episode 1. You'll now see that our folder structure for our engine will now match the same folder structure as our project, and that will be handy to keep everything in line. The next thing we can do is come up to Switch Views, go to Folder View and select on our episode 3 folder. We'll now be able to see our Olympus project and its folder structure available. Just the same as we have for our blank project, let's create ourselves a source folder to work from. We will want to optimize our engine straight out of the gate, and for this we're going to need some pre-compiled headers. Currently, in our blank project program, we already have a set of files called pre-compiled headers, and if we were going to do this for every program, then it will become rather confusing. One way that we can conquer this is to use the same name for our pre-compiled headers as we did for our program name. So I'm going to create 2 new files, one called olympus.h and the other one called olympus.cpp. These will act as not only the pre-compiled headers for our engine, but they'll also give us a way to link our engine to our blank program using the header files. Once we've added that, we can go back to our switch views, click on our solution view, and we'll be back to our solution. We haven't added those yet, so let's once again create a new folder called PCH. Let's add those files now. Let's go to our source folder, select on the 2 files we've just created and import them. Next we're going to need to set up the configurations for our project. So let's go up to our project, right click and click on Properties. The configurations that we're going to use here are mainly going to be the same as our blank project. So we're going to go over this nice and quickly. Let's open our configuration manager and let's just make sure that all instances of the x86 architecture is removed. Once this is all done, we can close this off and we'll be able to see that we're no longer running any instances of x86. Let's double click on our blank project and copy the build settings for our project and just paste those back into our Olympus engine. These paths are quite generic, so we can use them for both of our programs the same. Once we've done that, let's click off of that and just click Apply. Now that's done, we can start looking at the configuration type for our engine. Our blank project is an EXE, but we only need one executable. What we will need is to be able to link this into our program. And for this, there are two options. We could use a static library or a dynamic library. We're going to use a dynamic library. Once that's done, let's just set up some of the generic Windows settings to ensure that they're all at the maximum level possible. The next thing we need to do is add our precompiled headers. So let's come into here and go to precompiled headers. If we come up to here, we can just change this to create as we did before. And we can now change our standard affix to olympus.h. That means that our precompiled headers are now fully set up. So if we just click apply, then we can be confident in the fact that our engine is now set up. Now that we've finished setting up our configurations, we can move on to setting up our precompiled headers. Like always, the first thing we're going to need to do is include the name of the PCH file. For us, this is olympus.h. We can then move on to our olympus.h file. Like with all of our header files, let's add pragma once at the top. And then what I like to do is include our windows.h file. With our windows.header file, however, I want to do something very specific. I want to say that we should only be using the windows.h file if we're running on a Windows architecture. We're not going to be covering any other architecture, but it's something that you as a viewer might want to add later. Let's just add this here, and let's say if defined Win32, and this is a specific macro that Windows gives us to represent that we're running on a Windows architecture. Then please add the Windows header file. To make this work, we'll need to add in an ndif as well. Now that that's done, our Windows header file will only be operating if it recognises the Win32 macro, which at the moment it's not seeming to recognise. To make this work, we're going to need to come back up to our Olympus project and go back into the configurations. If we come from our link out and go into System, we'll see that we're currently set to a console box still. This is okay, but we're just going to set this to not set for now. Let's click Apply. If we come to C++, we can come to preprocessors, and currently our preprocessors are set to different options. Let's go to each of these and change underscore console to Win32. Let's do that for that and just click Apply. And I'm also going to do that for our release configuration. You'll see we've got the debug settings here, so I don't want to affect that. That's why I'm doing it on both settings and not just on one. Again, let's click Apply here and OK. Come back to all configurations and just go and click OK. That will just hopefully save that for later. Now we've done that, we can see that our Win32 macro is now working successfully. This is a good start for setting up our game engine, but now we're going to need to look into other things such as building the application itself. Now we've finished setting up our Olympus Engine project, it's time to start thinking about the overall design for our program. We now have two specific programs in here, our blank project, which is our game, and our Olympus Engine, which is our engine. What we'd really like is a file in our blank project called application, and for us to be able to run our entire program from this file. Let's start by going in and creating a new file for us to use for this process. Let's go to Switch Views and go down to our folder view. Let's go to our Episode 3 folder and blank project. In our source folder, we're going to create a new file and we're going to call this application.h. We'll also need our application.cpp in here as well. Once that's done, let's go back to our switch views and back to our solution view. We will need to add our files in here as well. Let's go to Add Existing Files, go to our source directory and add our two application files. Let's ensure that our .h files always go in the public folder. With that done, we can start looking into how we would like this to now operate. The first thing that we need to do is just add the include files for our application class. Let's start off with our PCH files, and then let's add in our application.h file as well. Once we've done that, we can move over to our application.h class, and I've made us up a class already that gives us the basics of what we need. I've called the class application just to keep it nice and easy. I've added a constructor and a deconstructor in here just to start and open and close the class. I've added an initialize variable or function which will give us an option to run this when we start the application, and I've added an update function which can come in here and be ran once every time the application loops. This is a good way to actually run our application. Let's just add the refactoring in here for all of these different. Visual Studio is now being rather annoying, so let's just do that manually. There we go. And that is correct in here. Now this is the way we want this to operate, and this is going to be a great way for us to operate, but we know from when we were setting up our Win main class earlier that this is not specifically how this functions. We don't just magically create a class, run initialize and update throughout the process. We're going to need to make a system to be able to tell our application or our game that this is how we want it to run. We do not, however, want to waste all of our time programming all of this information directly into the game itself. We would like to have some background code that just says, when you start up this program, please just run from the application class. To do that, we're going to need to create what we call an interface. And an interface will go behind this class, just have it basically running as a generic class that is built into every version of the engine, but is dynamic and adaptable for our specific variable of the engine. To do that, we're going to need to create a new class. So let's come up to our switch views, come down to folder view, episode 3, the Olympus Engine. Let's come down to Olympus this time. Now, we need to think about how we're going to organize this. There's going to be lots of different files that go into our actual engine itself, and we need a way to make sure that we know where to find everything. This application is going to be based heavily on a Windows application, and it's only really ever going to come out if we are using Windows. I'm sure if we were using a different system, there would be a whole different set of commands that we would need to input. For this reason, let's create ourselves basically a Windows folder. But Windows is a platform, so let's start by adding ourselves a platform folder. Once we've created the platform, we can actually add Windows. Now, The specific type of Windows C++ program we are using at the moment is called a Win32 program. There are other types of Windows programs that you could use as well, such as a UWP window. For this reason, I'm going to call this Win32. We could put this in its own separate Windows file as well, platform Windows Win32, but I think just by putting it as Win32, that gives us the amount of folders that we need to just understand this correctly. Once we've added our Win32 application folder, let's add a few classes into here. We are going to be making an application interface, and the standard way of making something like this is to keep the same naming convention, but just to add the letter I at the beginning. So we're going to create an I application.h, and we're going to create an I application.chapp. Let's just, while we're here, think about how we want this. Currently, in our program, we have our win main, and that's our main entry point. In our engine at the moment, we don't have a win main, and really, we would like all of that to be just kept and dealt with by our engine, and not so much in our system. To do this, what I'm going to do is I'm going to make a generic and callable win main function, and we're going to place it straight in its own folder, and we're going to call this winentry.h. And that's just so that we know that Windows will enter by this class. Now that that's all done, let's go back to our solution view and have a look and import what we've just created. Let's start by adding those into our application first. So let's come down to our private and our public files in our Olympus engine, and let's just add the same filters that we added a minute ago. That would be platform and Win32. We need to do that both times here, so let's just add his. And let's add a Win32 folder here as well. Now we've done that, we can just go in and import the files that we just created a moment ago. Let's go source, platform, Win32, and I'm just going to add all of these in here. Remember that we need to drop our .h files into our public file. Let's start with our application interface class, and just let's add the normal PCH files that we added in normally. That's going to be include Olympus.h in this case. And we are going to be able to include our I application. You'll notice at the moment this is coming up in red. It's not recognizing our normal PCH file, and that's because this program, this function, is actually located 3 steps ahead of our Olympus.h file. We can solve this by adding a forward propagated input directory. Let's go into our project properties again, and we can come in here to C++, we can come to general, additional include directories, and what we're going to do is we're just going to add the source directory of the Olympus engine. If we add the source here, it will add that in. And this means that we can now propagate forward in our folder system instead of having to keep going backwards in space inside our own program. It's a really handy way of just being able to get rid of these little errors where you'd have to go backwards in a folder. Now we've done that and we've added that to the system, we can come back to our I application class. Now the application interface class is basically a set of instructions for how we want our application to run. It's basically a promise to say, when I'm creating this class, the class that's created off of it in the future is guaranteed to be like this. And for that reason, I'm just going to start by copying and pasting our normal application class and putting it into our I application class. This is, for all intents and purposes, what we want our class to look like. I'm just going to add the normal I in front of each of these. That's just to show that this is an interface. To be able to make this, to say we need a contract that says when and how this is going to function, we need to add the virtual flag at the beginning of these functions. This says that we're not specifically going to create these right now, but when you create this in the future, make sure you add these, otherwise it won't work correctly. If I just add equals 0, it just means I don't actually have to create any of these functions right now. These would only ever need to be created once we actually created the inherited class. I'm not putting a virtual flag on my constructor. I've done it on the deconstructor because we may want to change the way our program is deconstructed. But on my constructor, we generally want to keep this the same. For that reason, I am going to refactor that, and we will create that in iapplications.cpp. This is now a contract for how we want our application class to match, and once we've added it together, we'll notice that this works fine. But we don't have any specific way to actually add this to our blank project. The Olypus Engine files are not actually currently linked to our blank project and vice versa. So in the next chapter, we're going to be looking into this. A dynamic link library is used by telling the application and the compiler that when we start up an application, we want to specifically import or export a DLL. There's a command to be able to do this, and that goes directly in here between the class and the iApplication. This is defined as such. This one's actually set to import, so let's just change that to export. It will work the same for both. Now that this is in here, this is telling us that when we build this, we want to export the DLL, and then when we put it back into our application or our blank project, we want to then give it a declaration to say that we want to then import that. This can become slightly confusing to keep importing and exporting DLLs, and for that reason there's a specific way that we actually can make this really easy. If we come up to our PCH files, or in our case here Olympus.h, we can add this little magic function. This is a macro, and it says if we are detecting the build DLL macro in the predefinitions, let's add this line here. And if we're not detecting the build DLL definition in our predefinitions, let's use this one here. This one says DLL export, and this one says DLL import. However, both of them are running on the same macro, and that is Olympus_API. We can see right now that this one is the one that is in Pwink, and that is because we are not currently running this build DLL. To start with, before I go into how we actually change that, let's just add this to our application file. So instead of this, we can now just put in Olympus API, and that will work exactly the same. If we then come up to our Olympus project, what we can do is go to our properties, come to preprocessors, the same as before. Now we're going to have to do this for both of these. Let's go to debug, and let's add the one we just had. Now within our Olympus, we want build_DLL here, and let's do the same for our release files. Let's add that in here as well. Let's click apply and OK. If we now come back to our Olympus.h files, we'll see that now we have got this available. So this is now going to be our DLL export. Now what's the methodology of doing this? We've just told it the exact same thing and we've just added it to tell it to do it. The methodology of this is that we've now set Olympus to use this build DLL macro. But our blank project is not using this, which means it's still going to be using this one. So basically, if we build these files inside our engine, it'll export them. But if we try and use them outside of our engine, it will import them. And that's exactly what we need to be able to use a DLL. Now that's done, we can come back to our iApplication class and everything's working absolutely fine. But we still need a way to be able to tie this into our application.h file. What we ideally want to be able to do is we want to be able to just include our iApplication class here, and we want to be able to use this here. But our system is not going to recognize this because we haven't actually linked the files together. To do that, what we need to do is we need to come up to our blank project. We need to add the same type of files we added a moment ago. So let's go to General, let's go to our Include Directories. Now what we want to do is we want to include the Olympus source file. So let's come back to Olypus Engine, let's go to Olympus and Source, click Select Folder, and that's brilliant. That will now give us access to the Olympus Engine files. But just the same as we did for the Olympus files, let's make sure we can forward propagate this system. For that, let's go back to our blank project and let's import the source folder for our blank project itself. That way it means that if we need to backstep at all, we will not need to, we can just grab it straight from forward propagation. Let's just click OK there and apply. Now this is a bit of a trap. I have forgotten to put this back onto all configurations, and for that reason this is only set on the release version. Let's just copy and paste and let's put this back to all configurations and just put that in there. So for those who are eagle eye, we should know that this should be platform/win32/iApplication. That is now imported that incorrectly there. And that should be working absolutely fine. Let's just have a look in here to see if we can find any reason as to why this wouldn't be working absolutely fine. There is one more step that we do need to do in here. We need to come into our references. We need to click Add Reference. Go to Olympus and just add that as a reference. That will now reference that into this project so that every time we build this project, that will be in there as such. The last thing we're going to need to do is we'll just need to come to our PCH files and add our Olympus file that we actually created. That will mean that we can actually import the different files over from our DLL imports into this program as well. Once we've done that, we can come back to our application.h and we'll see that everything is working absolutely fine. And if we were to run this now, it would majoritarily work. For now, we've got our application class and we've got the inherited class that it's built from. But we've still got no way of specifically running this at entry. In our blank project file at the moment, we've got our win main class, and this is working fine at the moment. But, as I say, we don't really want to run this class in this project. We'd rather have this back. So what I'm going to do is I'm going to start by just copying and pasting this section here. And then I'm just going to edit this out and just comment it so it doesn't run at start. I'm going to come back to the win entry file we created earlier. And in here, I'm just going to add the Olympus Engine header file. From here, I'm going to then add our win main. Let's get rid of all of this. Our win main is now located in our engine file. To make this work, we need a way of referencing our application class from our blank project in our engine. And as standard, this is generally the wrong way round. We would generally never reference our blank project in our engine, whereas we would reference our engine and our blank project. But we need to find a way to be able to do this, because we want our engine to be able to say, please run this class at entry. The way we can do this, let's have a look at this now. If we just go auto, and then we're going to say the entry application. And we need a way of pointing this towards the class we've created in our blank project. The class we've created in our blank project is going to be based off of an iApplication class. If we make a pointer to that, what we could do is we could now make a new class, and we could call this entry application. Let's put that up there as so. This mini function we've just created is being created on the intention of drawing back the application class from our blank project. So we need to create this in a way that we can declare that again later. Let's just create this as an external class for now. And let's make our auto entry application that we just created a moment ago, let's turn that into our entry application. Now I understand this is getting confusing, but please bear with me. We then need to find a way to be able to declare how we are going to actually declare this inside our class. To make this work correctly, let's just start by actually adding in the iApplication class. Now that's done, this is all working correctly, and we've got a few errors, but in general everything is working. Let's go back to our iApplication class, and let's add a new macro. This macro is as such, and it basically says, if we declare this function inside our application with the class that we want to run, that will translate that into our entry point. If that can translate into our entry point, we can then run it from here. This is a little bit confusing, but I'll show you how we can now implement that. If we come here, we can take this as such. We can come here. Now we're going to be very careful, and we're going to ensure that we go to our .cpp file for that, and there's a good reason for this. Let's include our win entry function that we created a moment ago. That's in there now. That means our win main is being called in, and we can now click entry app. We can change this to application. We have now said that through this macro we are going to feed in our application. That through this macro is then going to translate into our entry point, which if then we come to our entry things, our entry application, we're going to change this around. I've just realized it's entry application here and entry app everywhere else. Entry application, there we go. If we now come back to here, this is recognized here. We're also going to actually need to find a place to put this external application that we're going to be using. So let's go back to our iApplication class, and just here, outside of our actual class itself, let's just pop that down there. If we now make sure this is here as such, we can come back to our win entry. Just want to make sure that this is definitely coming up correctly. That should work as such. The reason this isn't working is because I've named them the same thing, so if we just very quickly get rid of this here, then that should open that up as such. Now that this is working correctly, let's go back to our application class and let's have a look again at how this is running. We're going to create our application. At the very beginning we're going to run initialize, and then we want to call a loop to update each time. Let's try and get that working for now. So we've created our application there. We can go entry app, and then we could go initialize. That means we can now use that at the very beginning when it runs. We can actually now test this on its own. Let's come back to our application class and let's just make a simple message box to say that this is now loaded up. Let's try and run this now. This isn't currently working, and one of the main reasons here is it's saying that it cannot find our Olympus.dll. To conquer this, what we need to do is we'll need to come up to our Olympus.engine file, and we need to come to our build file. At the moment, they're in two separate files because of the way we set it up earlier, but they actually need to be in the same files. So if we come up here to blank project, or Olympus, we should be able to come in here and we should be able to see a DLL. Now there we have another issue here, and this is actually telling me that it doesn't like this here, so let's just change that to here for now, and let's just build this again down here. That's builded successfully, and we can now find our Olympus.dll file in here. Let's copy and paste that, and let's just put that in our blank project file. If we were to now come down up to here, we can go to blank project and we can right click this and click on set as startup project. That means if we just now press play, out of these two files, this one is going to be the one that is run. Let's click that now and see if we can get our entry box. We can now see that from here, we've gone through our WinEntry system, we've used our background inheritance to actually run and initialize that. However, by going into our application class and using this macro, it's helped us jump ahead to be able to actually run this class. From that, we have all of that functionality, and the only actual functional class we have in our program at the moment is this one. And that's how we make a good game engine. Now that we've done that, we can just stop for a moment and let's go back and wonder how we're going to get this update feature. Let's come back down to our win main file that's here. And let's have a look at our Windows process. Not the Windows process, we want our message loop function. Let's copy and paste this now, and let's bring it across to our WinEntry. Let's drop it down here. This means now that the program is going to continue to run and loop over while they're looking for messages from our system. What we could do here is we can say, if you get a message, let's peek message, but if not, let's run entry app. .update. That is now going to give us not only our initialize function, but also our looping function as well. Let's come back to our application and let's just do this and just put another message box in here for updates, and let's just say loop. What we're going to need to do is we're going to need to insist that we build our Olympus folder and make sure that this is definitely the correct project that we're working from. We've just rebuilt our DLL, so we need to make sure that it's completely up to date to be able to run it. Replace the file in there as such. Click on play. We'll get our first box to say I've loaded up, and then Repeatedly after that, this same message will repeat and loop. We've now created a new application to run our blank project from. This application has both an initialize function and an update function that we can use to start building our project on, or our game on. This is powered in the back end by an engine now, with a built-in constructor and a built-in entry function. This is a really good start because it means we've got our entire project in just these simple functions that's nice and easy to read, and we've got all of our background logic in our engine. In the next episode, we're going to be looking into some of the next things that we need to think about when creating a game engine. For this reason, we're going to be adding some new per game settings, and we're also going to be adding a log system so that we can start to read information from our engine. And with all that said, I wish you the best of luck, and we'll see you next time when we'll be making a DirectX ready game engine.